Hello Year 12. So this week we are starting Chapter 3, Sequences and Series. For the most part, this chapter is reasonably straightforward. It requires you to learn a few formulae, and it's basically plug some numbers into the formulae, solve the resulting equations. There's a little bit of new notation here as well. In terms of the applications of sequences and series, it is massively applicable in real life. It's used for modelling population growth and decline, and the spread of a virus, economic growth, and so on. Okay, I'd like you to just pause the video. This is a throwback to GCSE, and just see if you can jot down the nth term for each of these sequences. So my guess is that you got the first two reasonably straightforward. Linear sequences or arithmetic sequences, we're adding 3 each time, and then subtract 1 to get to our first term here. For the second sequence, we are subtracting 5 each time. So our sequence is minus 5n, and then to get from minus 5 up to 10, we add 15. So to work these out with just some methods that we showed you at GCSE, they're still fine and they get us the right answers. We're going to show where they come from now. For the quadratic sequence, this is one that we recognise is just n squared. And then by comparing the next one to n squared, we can see that this is n squared plus 1. Now, geometric sequences were also at GCSE. We don't spend too long on them though, so you're forgiven if you didn't remember these, didn't get these right. First one, just 10 to the power n. The second one, we are multiplying by 2 each time. Our first term is 3, and so our nth term would be 3 times 2 to the n minus 1. That comes from this formula, a times r to the n minus 1, where a is the first term and r is the common ratio. Don't worry too much if you've forgotten that. We are coming back to that and we'll be using it again. The one just above it is the same formula. My first term is 10. My common ratio is also 10. So I've got a is 10 times r, which is 10 to the n minus 1. And then using my index laws, that's where I get my 10 to the n, but it's the same formula here that can take us there. Okay, as I say, we'll be coming on to geometric sequences and series in a bit, but for today, we're looking at linear or arithmetic. Okay, so in terms of our overview, you'll hear me talk about sequences and series. Basically, sequences is what we've been doing at GCSE all the time. It's just a list of numbers. It could be a list of letters or other things, pictures, but here we're just going to focus in on list of numbers. Series is what happens when we add the terms of the sequence. So here we can see an arithmetic series, 2 plus 4 plus 6 plus 10, okay, plus 100 and so on. So arithmetic sequences, geometric sequences and series we'll be doing. The only other things that we'll be doing in this chapter is some sigma notation and then recurrence relations. So as we've said here, so let's get to that one. So we've got our linear sequence where we're just adding 3 each time, linear or arithmetic. Okay, so arithmetic sequence where it's got a common difference between each term, and here where it's a common ratio where we're multiplying between each term is a geometric sequence. The other type that we will be looking at in this chapter is recurrence relations, and that's where the term in a series, the term in a sequence is determined by the preceding term or terms. So, for example, Fibonacci sequence. Each term is generated using the previous terms, and we'll come on to those recurrence relations later. So first of all, just a little bit of new terminology. when we talk about the nth term, we can use this notation UN. Okay, so UN is the nth term, U3 just means the third term. Sometimes you also see this notation, TN, which is the nth term, exactly the same thing. Okay, so here my position, the third term is 8, so U3 would equal 8. Okay, so we always use A for the first term of our sequence and D for the difference between the terms. So if I write a general arithmetic sequence, my first term I'm going to write as A, my second term would be A plus D, whatever the difference is I'm adding each time. My third term I'm going to add the difference again, so I get another D, A plus 2D. If I go to my fourth term, it would be A plus 3D. My fifth term would be A plus 4D. So my nth term is A plus n minus 1D. Basically, I've started at my first term and I've had n minus 1 lots of the difference added. Okay, now how does that fit with what we've already done before? So actually, what we showed you before was look for your common difference, put that number in front of n, and then figure out what you do to get back to the first term, right? At A level now, we're going to be we need to be using this formula, A plus n minus 1D. So let me just show you. Here, my nth term, UN, is my first term, which is 2, plus n minus 1 times my difference here, which is 3. Well, normally I would write that 3 at the front of the brackets. So 2 plus 3 times n minus 1. We'll multiply that out and then simplify, and we get 3n minus 1. There's no surprises there. If I look at the next arithmetic sequence that you did on the do now, same kind of thing. I want to be thinking in terms of A plus n minus 1D when I'm working out my nth term. UN is A plus n minus 1 times my difference here is minus 5. So again, I'm going to put that minus 5 to the front. So we would normally multiply it out and then simplify. 15 minus 5n. Again, no surprises. Okay. So in terms of how we're going to be using this, not too tricky, just have this A plus n minus 1D in your head, and here we go. So the nth term is given by that formula, and I want the first 3 terms, so nothing more than you would have done at GCSE. First term U1 is 55 minus 2 times 1, which is 53. U2 is 55 minus 2 times 2, which is 51. And U3 is 55 minus 2 times 3, which is 49. They're my first 3 terms. And I can see again, no surprises, I'm reducing by 2 each time, decreasing by 2. Part B, the first term in the sequence that is negative. So using my formula, I want when is 55 minus 2n less than 0. Solving that, add 2n, divide by 2. 27.5 is less than n. We know n is our position term, it has to be whole numbers, and I want the first n that is greater than 27.5, therefore n equals 28. Always do a little check. U of 28 is 55, sorry, U28 is 55 minus 2 times 28, and that gives us negative 1. As my sequence is decreasing by 2 each time, U27 would have been plus 1, U29 would be minus 3. You can see that's the first term that is negative. Okay, in example 2, nth term of each of these again, you can look at these and you can already do these, and that's absolutely fine. So we're adding 14 each time, so it's 14n, and we want to get to 6 for our first term, so it's minus 8. This one, we are subtracting 7 each time, so it's minus 7n, and then to get from minus 7 to 101, we're plus 108. However, at this stage, please do write down what A is and what D is. So for the first one, A equals 6, and our common difference here is plus 14. So my nth term, un, is A plus n minus 1d, so it's 6 plus n minus 1 times 14, and then simplify. Do show this working, please. 14n minus 14 equals 14n minus 8, as you expected. Same for B. Please write down A is 101, D equals minus 7, and plug it into the formula. U of un equals 101 plus n minus 1 times minus 7, and then simplify. You'll get your first marks at that point for using the formula. So it's 101 minus 7n plus 7, 108 minus 7n. Okay, in this textbook example here, there's actually 2 ways of answering this. We'll start by answering it with the information that we're given. un equals an plus b. So I'm given that u3 equals 5. So u3 equals 3a plus b, and we're told that that is equal to 5. u8 will be 8a plus b, and we're told that that is equal to 20. And then we solve these simultaneously. From here, I'm going to subtract to give me 5a equals 15, so a equals 3. Plugging that back into here, 9a plus b equals 5, so b must be minus 4. And check here, 24 minus 4 equals 20. So I found my values of the constants a and b. Now, an alternative way to that, and one that is very common, is using a plus n minus 1d rather than the formula up there. So here, if I'm told what u3 is, I know that u3 is a plus 2d, and that is equal to 5. And u8 must be a plus 7d, and that is equal to 20. Solve these simultaneously. I will get 5d equals 15, so d equals 3. Plug this in this example here, and I will find that a equals minus 1. Now, what I've worked out here is the first term and the common difference. So I would have un equals minus 1 plus n minus 1 times 3. And then I would have to simplify this. Minus 1 plus 3n minus 3. And that gets me back to 3n minus 4, which relates to the a and b in this first method. Okay, so in this first method here, we were using the an plus b that we were given. In this second approach, we were using what you will most commonly use in these type of questions, the formula, which gives us u3 is a plus 2d and u8 is a plus 7d. Okay. On to the next example. For which values of x would this would minus 8, x squared and 17x form the first 3 terms of the arithmetic sequence? The thing about an arithmetic sequence is that there is a common difference. So the difference between x squared and minus 8 would be the same as the difference between 17x and x squared. Okay, if that's term 1, 2 and 3. So the difference between x squared and minus 8 must be the same as the difference between 17x and x squared. That then gives us a quadratic to solve, which leads to these two answers. Okay, now work through exercise 3A and then come back to watch the video for exercise 3B.